All right, welcome to Unit 8. Our 8.1 notes are going to be a little bit of review and a little bit of new. We're going to start by reviewing how to multiply powers that have the same base. So first we're going to look at this little table, fill it out, talk about what exponents are, how they work. So when we have 2 to the first times 2 to the first, we can expand that. 2 to the first is just 1, 2 times 2 to the first 1, 2 would just be 4, right, which is 2 to the second power. 2 to the second times 2 to the second would be 2 2's times 2 2's, or 4 times 4, right? And this gives us 16. That is 2 to the fourth. 2 to the third would be 3 2's times 2 to the first 1 2. That gives us, grouping them, that gives us 16 as well. 2 to the third, 2 times 2 times 2 times 2, 16. That again is 2 to the fourth. So what we can remind ourselves of is these exponent rules. When we are multiplying two like bases that have exponents, we can add the exponents to figure out what power of 2 we're actually raising it to. So this is called product of powers, and that's what's in this box right here. Product of powers is the product of two powers of the same bases equals that base raised to the sum of the exponents. So our little shortcut trick there is to add our exponents. So on this 2 to the fourth times 2 to the second would be 2 to the 4 plus 6. 2 to the 4 plus 2, which is 6. 2 to the third times 2 to the third would be 2 to the 3 plus 3, which is 2 to the sixth as well. Okay, so that's a little bit of review. We've worked with exponents before. We've done these types of problems with these before. We're reminding ourselves how it works because we are going to get into some more complicated exponential problems. So on this first one, example 1, 3 to the second times 3 to the fifth. Again, using our product of powers property, 3 to the second times 3 to the fifth would be 3 to the 2 plus 5, or 3 to the seventh. This one, we can only combine those terms that have like bases. So we have the 2's here, 2 to the fourth and 2 to the negative second. That would be 2 to the 4 plus negative 2, or 2 to the 4 minus 2, which is 2. So we have 2 squared. And then we also have some 3's, 3 to the fourth and 3 to the second, and we can simplify that by going 3 to the 4 plus 2, which is 3 to the sixth. Now, could we simplify both of these further? Yes, right? 3 to the seventh simplifies here to 2,187, which you can just go 3 times 3 times 3 7 times, or if you're using a scientific calculator, there's a special exponential button. 2 to the second times 3 to the sixth would be 4 times 3 to the sixth, which is 729. So this simplified would be 2,916. So again, with numbers, we can go pretty far. We can simplify all the way. And then we get into some problems with variables, and our answers aren't going to be a number. They're going to include the variables in them. So example 2, we're going to simplify. We're going to take the numbers that we have, these coefficients, right, 4 and negative 3. We're going to multiply those together. We get negative 12. And then the variables here, x to the fifth times x to the second, becomes x to the 5 plus 2, right? X to the 5 plus 2, or x to the seventh. So there's our fully simplified expression. Fully simplified means that there are no parentheses, every fraction is fully reduced, and that there are no negative exponents. M to the second times m to the third, and n to the fifth, n times n to the fourth. Okay. Example 3. Again, we're going to take our coefficients and multiply them together, and then our like terms and combine them, multiply them together. Okay, negative 3 times negative 2 is positive 6. X to the first power times x to the third power would be x to the fourth power, and y to the third power times y to the first power would be y to the fourth power. And that's all we can simplify on that one. We get rid of the parentheses, make sure there are no negative exponents, make sure any fraction is fully reduced. Okay, here we have an addition in the middle. Okay, take note of that because we can only add or subtract like terms. We can multiply or divide, whatever we want, but we can only add or subtract like terms. So we're going to do the first section here, or the first part of this expression. First, simplify that. Negative 2 times 4 is negative 8. Y times y cubed is y to the fourth. And then we've got plus 3 times negative 6 is negative 18. Y squared times y squared is y to the fourth. So then we look here and we have like terms, both of these terms have a y to the fourth. Here we go. To combine like term, or to combine terms, to add or subtract. To add or subtract. They have to have exactly matching variables. That means they need to have the same variables and their variables need to be raised to the same power. So in this one, we have 2y to the fourth, so we can go negative 8 minus 18, and that is negative 26, and then our variable does not change, right? So when we're adding or subtracting variables, if they are like variables, the variable doesn't change. And we know that, right? 2x plus 3x is 5x. Not 5x squared. So sometimes when we throw those exponents on there, we get our rules mixed up. You can always simplify. Think of a simpler problem, right? This would be a simpler problem. Think about how it works and then apply the same rules to the more complicated problem. Okay, example 4. Throw in a couple extra terms in there. So let's see what we have. So I'm going to take my numbers first. So negative 2 times 5 times 3 times negative 7. Okay, if you multiply all those together, negative 2 times 5 is negative 10. 3 times negative 7 is negative 21. So we'll end up with a positive 210. Did I do that right? Yes. And then we'll take the y terms next maybe and see what we can simplify there. We have a 1y, we have a negative 2y, and we have a positive 2y. So that will be y to the first minus 2 plus 2. 1 minus 2 is negative 1 plus 2 is positive 1. So we're going to end up with y to the first power. And I don't need to write the first power because y without an exponent means y to the first power. And then x squared is my only x term, so x squared is fully simplified. Okay, so my answer there, 210 times y times x squared, is fully simplified. Second part of this example, we are going to do in class. Or you can try it on your own, and then we can go over it in class. You see, maybe try this one on your own, and then when we go over it in class, you can check and see if you did it correctly. Okay, then we're going to look at fraction powers. So this should be new to most of us. Fraction powers we have not dealt with, and you didn't see it at all in Math 1 or Math 8 if you took that path at Granite North. So what we're going to look for in fraction powers, x to the 1/2. So the 1/2, whatever number is on top, is the power that we're going to raise whatever our base is. So in this one, this means x to the first because 1 is on top. And then whatever the number on the bottom is, our denominator, right? Denominator, and the top number is the numerator. It's good vocab to remember there because I'm probably going to use it in class, numerator, denominator. So whatever the numerator of our fraction is in the exponent is the power that we're raising the base to. And then whatever the number on the bottom is the root that we're trying to find. Like square root, cubed root, fourth root, right? In this one, we're trying the 2's on the bottom, so x to the 1/2 would simplify to the square root of x to the first power. So whatever the number on bottom is goes out in front of your root. But we know that a radical without a number is the square root. So it's a little complicated. It's going to take a little bit. Let's look at some examples, and then we'll talk about it in class as well. But don't be too overwhelmed because it is new, so it's going to take a little bit to get the hang of it. Okay, so example 5 is 4 to the 1/2. Okay, so again, using that 1/2 idea there, the denominator goes in front of our root, so we're going to look for the square root of 4 to the first power. And that exponent right there can go outside your radical or inside your radical. It doesn't matter. Okay, so what we're going to do here is we're going to find the square root of 4 to the first power. Well, 4 to the first power is just 4, so we're just going to look for the square root of 4, and the square root of 4 is 2, or more accurately, plus or minus 2, right? So 4 to the 1/2 is plus or minus 2. 27 to the 1/3. So again, the denominator is going to go in front of our radical. So what we're looking for on this one is we're looking for the cubed root of 27 to the first power. So again, that exponent can go inside or outside. A lot of times you want to do the radical first and then raise it to the power. So what we'll do here is we're going to find the cubed root of 27. Does anyone know what that is right at the top of your head? So cubed root, right, we're going to look for 3 of a kind. We know that 9 times 3 is 27, and then we know that 9 is 3 times 3. So we have a triplet here. And so in a cubed root, we're looking for a triplet, and only one of them will make it out. So the cubed root of 27 is 3, and then we're going to raise it to the first power. 3 to the first power is just 3. Now, cubed roots, we do not put the plus or minus in front, because if you had a negative cubed root, then your answer would be negative. And we can explain that more in class if you have questions about that. Okay, example 6, square root of, so 8 to the 1/2. Anything to the 1/2 power, you guys, this might be just a shortcut that you remember, okay? And this is kind of right here, right? Anything to the 1/2 power is just the square root of whatever it is. So anything to the 1/2 power is just finding the square root. So down here, we're going to look for the square root of 8. And again, that is the square root of 8 to the first power, but we know that's just going to be the square root of 8. Okay, so again, simplifying radicals, we're going to factor it, look for buddies when we're doing the square root. 8 factors to 2, 2, and 2, so one of them breaks out, one of them dies, and then one of those 2's has to stay inside. And it is a square root, so we're going to put that plus or minus in front. Okay, so this one gets a little more exciting because we don't have a 1/2 or 1/3. Okay, so again, the denominator will go in front of your radical. So we know we're looking for the square root of 4, and then we're going to raise whatever that is to the 3rd power. Square root of 4 we know to be 2, and then we have to raise it to the 3rd power. 2 to the 3rd power is 8. And we'll go ahead and throw that plus or minus in front because it is a square root. And if we had the positive 2 cubed, we'd have positive 8. If we had the negative 2 cubed, we'd have negative 8. Okay, example 7. We've got a 2 on our denominator, so we're looking for the square root of 9. And then the 5 is at the power we're going to raise it to. So we're going to take the square root of 9 and raise it to the 5th power. Square root of 9 to the 5th power. Square root of 9 we know to be 3. We're going to raise it to the 5th power. As long as that exponent is negative, or is odd. If exponent is odd, keep the plus or minus. Okay, so 3 to the 5th power is 243. And then because that 5 is odd, we're going to keep that plus or minus in front. All right, and then we will go over this last one in class. So go ahead and try it on your own, and then you can check and see how you did in class. That is it for 8.1. So look over these notes. Make sure you write down our key ideas here. Again, these fraction exponents should be new for most of us. So take some notes on this, and if you have any questions on it, you can email or message on Remind or write it down and ask tomorrow in class. See you guys soon.